Hi, my name is Guang and I'm 12 years old. For this lesson, we'll be continuing on with the techniques and applications for definite integration. For this lesson, we'll be having even more examples. So, our example for this lesson is given f(x) is equals to integral 1 to x cosine t squared dt. Find integral 0 to 1 f(x) dx. So first of all, how can we find f(x)? Are we able to find f(x)? So if you're saying f(x) by itself, then no. But if we're talking about was over inside over here already, then I'll explain it later. So first of all, functions like this, or it can be any that includes the variable square, cube, square root, or whatsoever. Like you can say e to the power of x cubed dx, and you would not be able to solve this. Because you are not able to solve it if it's like this, or if you're saying tangent t dt. Tangent t squared dt, you'll also not be able to solve it if you're talking about things like or e to the power of negative square root x dx. You'll still not be able to solve it because of these square roots, squares, cubes, sine theta, square d theta. You'll not be able to find what this is. So first of all, the different cases can be like number one, it can be like square root, square, cube to the power of whatever and all. And then for this part, because that our d theta and all, we do not have anything to make it as if it is sine theta d theta, like we do not have a theta in front to put it inside here to make a theta square. Or we do not have a x square over here to put inside to make an x cube to help us integrate these. So we cannot solve it, especially if it is indefinite integration. So if it is indefinite integration, you will not be able to solve these kinds of examples, including this. But what about definite integration? Definite integration, it still depends. If it is singular integration, then no, you still cannot find it no matter the boundary and all. So first of all, the integration must be definite. Second of all, it must be double or triple integration in order for it to be solvable. And lastly, the boundary of the other two or one integration, and the boundaries also matter, and what has inside also matters, because that for this part, if you only say like double triple integration, well, even if it's double triple integration indefinite, you still cannot find what these are. Well, on the other hand, if it's definite integration, for certain boundaries and for certain of these functions, you'll be able to actually solve it with these. Okay, so now that I have roughly talked about for our f(x) about how we cannot solve it if you try to solve f(x) by itself, or similar question with either indefinite integration, just singular integration, or the wrong boundaries. So now that we have talked about that, take a good end. Okay, so over here so the question over here is basically from 0 to 1, and then integrate over here from 1 to x cosine t squared dt dx. So we already know the boundary. Well, that means that, does that mean that we don't have to draw the graph? Well, we will still draw the graph and you'll see. So over here we have x and we have t, and then here 0. So apparently over here so what you have for x is basically from 0 to 1. And then for t we'll have from 1 to x, so it will still be 0 to 1. And then for this part, what we'll have here is that I will have this line, whereas what's the function of this line? It is t is equals to x over here. But what is the area bounded by for this case? It will be, because he integrated according to this t first, so over here for this part it will be like this, okay? But now that we think about it, if we integrate with respect to t first, wouldn't we be unable to solve it? What if instead we integrate according to whoops. I'll write that later. What if we integrate with respect to x first? So if we integrate with respect to x first instead, what we're going to have is that, so first of all, what will it be instead? So for this part, it'll be from 0 to t and all, right? So over here, we'll also need a negative for this part. So negative from 0 to t. And then after that, what about for t? For t, it will be from 0 to 1. Okay? So for our t, it will still be from 0 to 1. It's just that since we do x first, instead it will be from 0 to t. And now that we have gotten for this part, we can integrate for x straight away. So integration of a constant over here, basically the cosine t squared is a constant. It will be just the constant times x. So it will become cosine t squared x from 0 to t dt. So now you have gotten this, we can substitute the boundary inside to the x and you will get t cosine t squared dt. Now that we have gotten this part, what we are going to have is, so we can put this inside. Since you have t, if you put it inside, you'll have t squared. But what is t integrated? There will be a half, so it becomes negative half. Integrate from 0 to 1 cosine t squared dt squared. Now that we have this part, what we're going to have is, we can also integrate for this part because relatively speaking it will be the same as like cosine theta d theta. So we'll have, so cosine integration is sine. So here we'll have sine t squared from 0 to 1. Okay, now that we have gotten this, we can substitute this inside and we will get negative half sine 1 squared, which is still 1, minus this, which will become plus half sine 0 squared. Well, over here basically sine 0, but what is sine 0? So since sine 0 is 0, so our result will be negative half sine 1. So for this lesson, so this is the result that we get. So for this lesson, what we mainly did was, as we explained about why fx by itself, you cannot solve it. or if you're doing the double integration, in this case you cannot integrate according to t first. And other examples that consist like t cubed, t to the power of 4, square root t, and then it's like e to the power of sine, cosine, tangent, cotangent, and all those, okay? Well, for this part, we also explained that it will only be solvable if and only if it is definite, double or triple integration, and has certain boundaries and contents, okay? So over here, we also drew this graph, which represents about, so over here is basically what this is bounded by. And as we can get from the boundary over here, then we changed the boundary according to this triangle over here, and we get 0 to 1 and 0 to t with a negative in front over here, and we kind of just integrated respective to x first, then we integrate with respect to t. So that would be all for this lesson. Last but not least, thank you for your watching.